All right, everybody, this is 8.1, comparing functions. So we've learned lots of different type of functions: linear, quadratic, exponential, absolute value functions. We're going to be able to identify them based off of a graph or a table or a word problem. All right, so that's our goal for this part of the lesson. So first off, looking at these, this would be a linear. How do we know? So I guess that's part of the thing here is, how do you know? So don't leave that off when we do our homework and our test. So this is linear. Okay, how do we know? Well, it has a linear, it's a constant slope. Okay, so linear equations have constant slopes. Okay, next is a quadratic. How do we know? Well, it has a vertex, it has this growth pattern, 1A, 3A, 5A. It's a U shape, so anything like that would be sufficient, would be good. Okay, next this would be an absolute value function. We have a vertex, and it has constant slopes on both sides. Okay, and their slopes on both sides are opposite signs. So that's not actually one of the ones that we need to write down here. It would be like other, but if you wrote down absolute value, that would be great too. Next we got is exponential, so maybe other here, and this would be exponential. How do we know? Well, exponential functions, at least for all the types of problems we've had, is they don't cross the x-axis. It's always increasing or it's always decreasing, but it's not linear. So we've had lots of linears that are always increasing or all decreasing, but exponential functions grow exponentially, okay? All right, so now we can look at some tables. We'll start with B, all right? So one way we can figure out what type of function it is and to show our work on how we know is what's called the first difference. So you do the first difference, meaning we just find the difference between -1 and -5. So -1 minus -5 would give us 4. 4 minus a -1 would give us 4. So basically just the gap between them. So for all of these, we keep going, we see this pattern, okay? It's telling us that the first difference is all the same. And if that's the case, then it's linear. Basically, it's just being added. We add 4, add 4, add 4, add 4, add 4, add 4, okay? So that is linear when the first difference is all the same. All right. All right, next off we have this table. This doesn't look super promising. It doesn't look like here, the difference here would be 0. The difference here would be what? 2. So right away we know this isn't a linear function, okay? The slope here is 0, the slope here is 2, so it's changing. So it could be exponential, it could be quadratic, or it could be other. So to figure that out, we need to keep going. So 5 minus 1 is 4. 11 minus 5 is 6. 19 minus 11 is 8. And 29 minus 19 is 10. So you may notice, if we have our first difference, that there is a pattern here, okay? But they're not the same, so we know it's not linear. So if we see a pattern and it's not linear, what we're going to do is called the second difference. So we'll do the exact same thing. Here would get 2, here would get 2, 2, 2, and 2. So now, if the second difference is all the same, then what we say is it's a quadratic. Okay? And if you had to do like a third difference and they're all the same, then it would be cubic. So, but you're only going to do linear, quadratics, and exponentials. So first difference, we see a pattern. Second difference, they're all the same. We know it's a quadratic, okay? D, here, looking at it, you might already kind of see a pattern. What's going on, okay? If you do first difference or second difference, they're not going to work. The reason why is because this is being multiplied every time. So it's being multiplied by a half every time. And if that's the case, then this is exponential. So just think, is it being multiplied by something every time? You could also kind of think of it as division. It's being divided by 2 every time. So dividing everything by 2 every time is the same as just multiplying by a half. Okay? So this type of equation would be like y equals some initial value, like 128, and then you'd have like 1/2 to the x. Okay? It's being multiplied every time by a half, and it has an initial value of 128. Okay? You don't need to write down the equations, but you just need to be able to identify. And then for A, this one, you might want to say, ooh, is it exponential? It looks like it goes up and then up and up. But is it being multiplied by the same thing every time? So this would have to be multiplied by 4/3. And this would have to be multiplied by 2. So we know it's not exponential. So we might want to try first difference. So that would be 1, and then 4, and then 10, and then 13. Okay, so definitely not linear. Second difference, that would give us what? 3, and 6, and 3. So it's definitely not quadratic. It might be a different types of function, but those aren't what we're going to talk about. So we'd say other. All right, so we'd be able to identify the type of function is based off of a table. We can also do it based off of kind of like the context, like of a word problem. So for example, you pay $5.99 per month. Okay, this has a constant rate. Every month you have to pay that much, so this would be linear. Each point is exactly 1/3 of the previous point. So maybe the first point was 9, means the next point would be 1/3 of that, which would be 3, and then the next would be 1/3 of that, which would be 1, and 1/3 of that would be 1/3. So it's being multiplied every time by 1/3, so this would be exponential. All right, the speed at which Shane is driving down the road when he hits every red light. So he speeds up, drives, and then has to stop. And then he speeds up, and he drives, and he hits another red light. Okay, so this would be like an other example. Okay, it's not quadratic, it's not exponential, it's not linear. All right, D, path of a rocket takes when it's launched from the ground to where it lands. So anything that's like a projectile, something that's thrown up into the air, shot up into the air, this will always be quadratic. Okay, it goes up, comes back down. All right, at least we have to assume that, okay? The number of cell phone users is increasing by 75% every year. Okay, so this is like a rate. If you're given a rate, then it's exponential. It's like maybe it started with 100 cell phones, and then it's increasing 75%. So the factor would be like 1.75 to the x. So every year it's being multiplied by 1.75. So exponential. And then the last one, I'm just going to not do that one. Let's not do that one. Okay, we'll also want to compare functions, like looking at this table or looking at this equation, which function has the larger minimum. So larger minimum is like your y value, so how low it goes here is 7. And then this is an absolute value function. We know that its vertex is 4, 8. And again, that 8 is its minimum value. So which one has a larger minimum? That would be the table. Okay, because 7, just kidding, tricked you. 8, 8 is more than 7. So 8 is larger. That equation is larger. All right, oh boy, here we go. Which function has a lower y-intercept? So this is standard form, meaning that this is your y-intercept. And then for the table, we know the y-intercept is when x is 0. So the y-intercept is -4. So which is lower? Which has a lower y-intercept? That would be your table, right? So -4 is lower than -3. All right, last thing we need to talk about, and you've done a lot of this before, is rate of change, okay? You've talked about the slope formula in the past. That's like y2 minus y1 over x2 minus x1, okay? Where x1 and y1 is a point, and x2, y2 is like your other point. And we want to find the slope between those 2 points. All right, maybe you did this last year when you did linear equation, but if not, here's a nice review, okay? So this is how we find the slope, n. So we would take y2 minus y1 over x2 minus x1. So we'd get 2 over -4 or -1/2. So this would be the slope between those 2 points. You can also find the slope by looking at like a graph. You just find a good point, 2 good points, and you just want to say what's our rise over our run. 2 over 1. So here m would be 2 over 1 or just 2. So that is finding the slope from 2 points. We're going to do something very, very, very similar when we have quadratics. But the thing that you should notice is that quadratics are not linear functions. They don't have a constant rate of change. Okay? So if we looked at this table, the slope between these 2 points is 1, but the slope between these 2 points is 3. So we're going to need to figure out slopes when they don't have the constant slope. We want to find the average rate of change. That's why it's average between the 2 points. All right, so here is the average rate of change formula. This is kind of a fancy thing, a different way to look at this, but it is exactly the same as the slope formula, okay, y2 minus y1 over x2 minus x1. So it's exactly the same, it's just a different way to write it. So basically they're saying for the function f of x between this interval, okay, you'll also see it like this, a comma b, this is the interval between a and b, find the average rate of change. And here is, this is like the same as like y2 minus y1 over x2 minus x1. It's the same sort of thing. So maybe I'll even write that here. Okay, so we'll probably even just do that for all of our problems, just using the y2 minus y1. But anyways, so here is a quadratic. It's right here, and we want to graph it. So we talked about transformations. This is when like h and k would be 0. It would be its origin, and then would go over 1 up 2, over 1 up 6 on both sides. Okay. But they're asking what is the average rate of change over this interval from 0 to 4. So from here to here, what is the average rate of change? So how you do it from a graph is you just take that point, and we'd take that point, and we need to figure out our rise over run, which would be 8 over 2, which is 4. So the average rate of change between those 2 points is 4. If we want to do it algebraically, what we would do is we would say, well, x1 would be 0 and x2 would be 2. We basically just need to find what y1 is and what y2 is. So we would plug 0 into our equation, so that'd be 2 times 0 squared, which is just 0. And then for y2, we'd plug in 2, so 2 squared. So that would give us 8. So now we have our y2 minus y1 over x2 minus x1. And we'd get 8 over 2 or 4. So we end up getting the exact same thing. So this f of 0 is just saying evaluate the function when x is 0. And this is saying evaluate the function when x is 2, which is what we just did. All right, so here are just some other examples that we'll do. We have this equation. We want to find the interval or the average rate of change over the interval of -1 to 4. So again, this is like your x1 and this is like your x2. It's how far, like the domain that we want to use to find the average rate of change. So when we need to figure out what y1 is and what y2 is, so we plug that in, we get 2 times -1 minus 1, so that's -2 minus 1, or -3. And then for y2, we'd plug x in for 4, or 4 in for x. So 2 times 4 minus 1 gives you 8 minus 1, which is 7. And then we can use the slope formula. So y2 minus -3, so that's 2 negatives, gives you a positive. And then we do x2 minus x1, which is a -1, gives another double negative. So we'd get 10 over 5, which is 2. So we could have skipped all of this if we realized that this is a linear equation. And linear equations have constant slopes. It's just our m right there. So if you see a problem like that on your homework or your test, you could do what we did here, or you could realize that it's a linear equation and our slope is 2. All right, here's an equation that's not a constant rate of change. So we would definitely need to do this. So again, this is like your x1 and your x2. We need to find our y1. So we would plug all that in. So we'd get -2 plus 1 plus 3. So absolute value functions are kind of like parentheses. We need to evaluate what's inside that absolute value before we absolute it. So we would want to figure out what this is. Well, that's -1. And then we can make that become a positive. So we can't make anything be positive until after we just have one number left. So we just get 2 times 1 plus 3 equals 5. And then y2, same sort of thing. We'd plug 1 in, which will give us 2 times the absolute value of 2, which is just 2. So we'd get 4 plus 3 is 7. So then we'll write our formula. So y2 minus y1 over x2 minus a -2. So that would give us a positive 2. So 2 over 3. So our average rate of change would be 2/3. All right. Okay, you could probably even, for any of these, if you prefer, if you have some graph paper, I won't provide any like that on your homework or test, but you can always kind of do a sketch of it too if you wanted to try and find your rise over run, just like this. So here they want us to find the interval between 1 and 3. So here's 1, here's 3. So basically we need to find the points at 1 and the points at 3. And we can just use our rise over run. So it looks like we go down 4 over 2. So 4 over 2 is 2. Oh, but it's a negative, right? So we go down 4 over 2. 1, 2, 3, 4. Yeah. All right, for this one we have same sort of thing. We want to do it at when x is 1 and when x is 3. Up 2 over 2. Which is 1. All right, so I think that's it for today. If you have any questions, let me know. I'd love to help you out.